In these presentations, we are going to discuss about the recursive design parser in syntax analysis. So it is a top-down parser. So in the recursive design parser is use a procedure for each non-terminal. The procedure looks at its input and it decides which productions to apply for its non-terminal. The terminals in the body of the productions are matched to the input at the appropriate time, while non-terminals in the body result is calls to their procedure. General recursive designs may require backtracking. That is, it may require repeated scans over the input. So, however, the backtracking is rarely needed to parse a programming language construction. So, actually, we get the results by repeated scanning. So, we reach the definite results by using the backtracking concept. So, recursive design parsers support the backtracking concept. So, example, consider the grammar capital S implies small c capital A D. So, here only one non-terminal in the right side, so that is capital A has a small a b slash a. So now we want to construct a parse tree for the string w is z a d. So where our recursions process start from the starting symbol of the grammar capital S. It has only one right side replacement, small c capital A D. So the A has two replacements. So the compiler take a first right side replacement A B. So the capital A is replaced by A and B, small a and small b, but it does not match with the our target. So because our input string W is in CAD, but we get CABD. So now the compiler followed the backtracking concept. So here the A is replaced by the second replacement, that's in small a. So now we get the accurate results. So this is a backtracking concept, the recursive design parser. So it can be described by the step-by-step. So in this recursive design parsers has the following procedures. Initially create a tree with the single node label S and the input point to the C. So the first symbols of the W expands the tree with the productions of the S. The input pointers to C, the first symbol of W. So expands the tree with the productions of X. So already we discussed this procedure. The leftmost leaf C matches the first symbols of the W. So advance the input pointers to the second symbols of the W, A, and consider the next leaf of the capital A. So first and follow. So first is defined as a set of terminals that begins a strings derived from the alpha. So here consider a non-terminal capital A. It has the productions. Capital A implies alpha slash beta. What is in first of alpha and beta are included in the first of capital A. If the productions in the form of capital A implies epsilon, the first of A is an epsilon. If the productions in the form of capital A implies capital B, so the first of capital A is first of capital B. So this is the actual rule for the first and follow. So if you want to find the follow of any non-terminal, initially the first condition, if that non-terminal is a starting symbol of the grammar, means the follow of the starting symbol of the grammar is the dollar. Then for the follow, we have to check that non-terminal is available in the right side replacement or not. If it is available in the right side, what is the term to be followed? That non-terminal that is taken as a follow of particular non-terminal. So example, capital A implies alpha, capital B beta, where capital B has a following term beta. If the beta is a terminal, we can take that beta is a follower of capital B. If the beta is a non-terminal, we have to find the first of capital B, then that is a follow of the capital B. In this first of beta, if the epsilon is available, we find follow of A for the follow of B. So there are three possibilities. First, the non-terminal has a following term is a terminal, means that is a follower. The following term is a non-terminal, take the first of that term. In this first, it has a epsilon, we have to find the follow of the left side grammar capital A for the follow of capital B. So it's the procedures for the recursive designs parser. Then how to find first and follow for a given grammar. So the next we move to the predictive parsers. So it's a special case of recursive designs parsing where no backtracking is required. So predictive parsers does not support the backtracking concept. So just take first follow and predictive parser table constructions and check the string acceptance. So where consider the productions. E implies T eder. So here we must check the given grammar is an ambiguous or not. So if it is an ambiguous, it has left recursive. So we have to remove the left recursive. Sometimes some productions in the left factoring. So we remove both left recursive and left factoring by the corresponding formulation. So after that we find first and follow of each non-terminal available in the given grammar and move to the constructions of parsing table. So actually the input is the strings to be parsed followed by right end marker $. That means what are the which strings to be parsed, that is ended with the $. Then stack. So stack initially has the starting symbol of the grammar with the $. symbol. The parsing table, it is a two-dimensional array M of capital A comma small a, where capital A is a non-terminal and small a is a terminal or the $. The output give the output wherever the string is valid or not. Thank you.